study section 3, Measures of Location and Partition. Introduction. The three measures often discussed in statistics are measures of location, partition, and dispersion. This study session will focus on location and partition. The measures of location are also known as averages. To a layman, average means not too bad or not too good, especially when performance is being rated. To statisticians, average has a deep meaning. Also is the measure of partition, which divides a set of data into different parts, be it quartiles from quarter 4, deciles from decade or decagon 10, and percentiles from percentages 100. Learning outcomes for study section 3. At the end of this study session, you should be able to distinguish between the measures of location and partition. Discuss the relation between arithmetic, geometric, and harmonic means. Measures of location and partition. Measures of location are measures of the center of a distribution. They are single values that give description of the data. Since such data tend to lie centrally within a set of data arranged according to magnitude, then they can be called averages. The three types of averages are mean, mode, and median. These three are collectively known as measures of location. Each has advantages and disadvantages depending on the data and the intended purpose. Mean. This is often used and of great importance out of the three averages. There are three types, which are arithmetic mean, geometric mean, and harmonic mean. 1. Arithmetic mean. The arithmetic mean of a set of n numbers x1, x2 to xn is denoted by x bar and is defined as. However, if the numbers x1, x2 to xk occur f1, f2 to fk times respectively, that is, occur with frequencies f1, f2 to fk, the arithmetic mean is where n is equal to is the total frequency. Use of assumed mean. Sometimes large values of the variable are involved in the calculation of mean. In order to make our computation easier, we may assume one of the values as the mean. Then the revised formula for the mean is where a is the assumed mean, d is equal to x minus a, c is equal to constant factor or class size. For grouped data, mean is equal to 2. Geometric mean g. The geometric mean g of a set n positive numbers x1, x2 to xn is the nth root of the product of the numbers. G is equal to 3. Harmonic mean h. The harmonic mean h of a set of n numbers x1, x2 to xn is the inverse of the arithmetic mean of the reciprocals of the numbers. H is equal to relationship between the arithmetic, geometric, and harmonic means. The geometric mean of a set of positive numbers x1, x2 to xn is less than or equal to their arithmetic mean, but is greater than or equal to their harmonic mean in symbols. H is less than or equal to G, less than or equal to x bar. The equality signs hold only if all the numbers x1, x2 to xn are identical. Median. The median of a set of numbers arranged in order of magnitude, that is, in an array, is either the middle value odd or the arithmetic mean of the two middle values even. If the number of observations is odd, the median is. If the number of observations is even, the median is. And for grouped data, the median is obtained by interpolation, which is given by where LM is equal to lower class boundary of the median class, FM is equal to frequency of the median class, N is equal to summation F is the total frequency, CFB is equal to cumulative frequency before the median class, W is equal to class width or class size. Mode. The mode of a set of numbers is that value which occurs with the greatest frequency, that is, it is the most common value. The mode may not exist, and even if it does exist, it may not be unique. A distribution having a unique mode is called unimodal, while the one with two modes is called bimodal. From a grouped data, the mode is defined as where LM is equal to lower class boundary of the modal class. Delta 1 is equal to difference between the frequency of modal class and the class before it. Delta 2 is equal to difference between the frequency of modal class and the class above it. W is equal to class width. Relationship between the mean, median, and mode. For a unimodal frequency curves that are moderately skewed asymmetrical, we have the empirical relation mean minus mode is equal to 3 into bracket mean minus mode is equal to 3 into bracket mean minus median. Measures of partition. There are quantities that divide a set of data into different equal parts. Such data must have been arranged in order of magnitude. Some of the partition values are the quartiles, deciles, and percentiles. Quartiles. It divides a set of data in an array into 4 equal parts. For simple series, first quartiles, Q1 is equal to Q2 is equal to Q2 is a special quartile. It divides a set of data into 2 equal parts. It is also known as the median. Third quartiles, Q3 is equal to, for grouped data, first quartile, LQ1, take 2. First quartile, Q1 is equal to, where LQ1 is equal to lower class boundary of quartile 1. FQ1 is equal to frequency of the Q1 class. WR is equal to width of Q1 class. Summation FQI is equal to CF before the Q1 class. Third quartile. Q3 is equal to, where LQ3 is equal to lower class boundary of Q3 class. FQ3 is equal to frequency of the Q3 class. W3 is equal to width of Q3 class. Summation FQ3 is equal to CF before the Q3 class. Deciles. These are values that divide a distribution into 10 equal parts. They are denoted by DI, that is, I is equal to 1, 2 to 9, D1, D2 to D9. It is defined as D is equal to, well, LD2 is equal to lower class boundary of decile 2 class. FD2 is equal to frequency of the decile 2 class. W1 is equal to width of decile 1 class. Summation FD1 is equal to cumulative frequency below the decile 2 class. Percentiles. These are values that divide a distribution into 100 equal parts. They are denoted by P1, P2, P3 to P99. For example, a group distribution The 79th percentile is defined as P79 is equal to, where LP79 is equal to lower class boundary of 79th percentile class. FP79 is equal to frequency of the 79th percentile class. W1 is equal to width of 79th percentile class. Summation FP79 is equal to cumulative frequency below the 79th percentile class. Example 1. The table below presents the frequency distribution of marks out of 50 obtained by 49 students in a statistics text. A. Compute 1. The arithmetic mean. 2. The mode. 3. The median. 4. The upper and lower quartile. 5. The 70th percentile. B. Justify the relationship harmonic mean less than or equal to geometric mean less than or equal to arithmetic mean using 49, 71, 38, 57, 89, 66, 92, 74, and 83. Solution. X bar is equal to, recall X will be the class mark which is obtained by adding the lower and upper class limits and dividing by 2. 1. X bar is equal to 20.9694. 2. The mode is equal to 18.3571. 3. The median is equal to 19.9. 4. The upper and lower quartiles, Q3, is equal to 36.75, approximately 37. The class interval 20 to 25 has a cumulative frequency of 36, while 25 to 30 has a cumulative frequency of 41. Therefore, the class interval 25 to 30 will be used in obtaining Q3. Q3 is equal to 25.4. Q1 is equal to n over 4 is equal to 12.25. The class interval 15 to 20 will be used for Q1. Q1 is equal to 15.0. P70 is equal to 5 is equal to 24.48. B. Mean is equal to 68.78. G is equal to 66.38. H is equal to 63.75. Therefore, H is less than or equal to J less than or equal to X bar, since 63.75 is less than or equal to 66.38 less than or equal to 68.78.